Welcome to one of the most mysterious and unexplored places on Earth. But what's so special about that? It's just some icy peaks and the endless snowy expanse of Antarctica. Yeah, that's right, but there's still a planetary scale mystery here. No matter how hard you try, you won't see a hidden mountain range, giant, unexplored land where no human has ever set foot, and it lies under another layer of mountains. It's like a nesting doll, but the size of a continent. These mountains hide Antarctica secrets, and these secrets can tell us something awesome about the ancient history of our planet. This gigantic unexplored territory in Antarctica is called the Gamburtsev subglacial mountains. And the layer of ice above keeps this place untouched by nature and people. It's like a land inside another land, and it hides more than just mountains. There are valleys, hills, and plains. The whole area is similar to the European Alps, but unfortunately, we can't enjoy the view. Those mountains were first discovered in 1958 using seismological instruments. More than half a century has passed since then, and this place still remains one of the most poorly studied tectonic objects on Earth. Why? Because it's ice. A lot of ice. Who knows? Maybe there are some unknown ancient artifacts lying there. What if they're hiding a secret city or spaceships? It's unlikely, of course, but it would still be interesting to look there. Think about it. Hundreds or even thousands of miles of land that have remained unchanged for hundreds of millions of years. Even if no new species of animals or remains of an ancient civilization are there, this place still has a history. The history of the formation of continents on our planet. And scientists have already figured out some of this story. The mountains buried in Antarctica were originally like ordinary mountains, but as a result of a planetary scale event, they just… Wait a minute. Have you ever wondered how mountain ranges are formed? We see them in real life, in movies, in photos on the internet. We climb them. But how did they appear? Mountains have not always existed on the planet in this form. They appeared as a result of a large-scale collision of tectonic plates. Two giant solid chunks of ground are moving toward each other, then crash, and boom! Millions of tons of the Earth's crust pile on top of each other, mix, and form ledges and gorges. And all this can last for millions of years. Yes, it's a disaster, but it's very slow. Some tectonic plates are still colliding. For example, the Himalayas continue to grow because the Indian and Eurasian plates are still ramming into each other. And this process began about 50 million years ago. The Gamburtsev Mountains under ice experienced a similar event, only much earlier. An article in the journal Earth and Planetary Science Letters says that they appeared during the formation of the supercontinent Gondwana. Two giant pieces of land were separated by a boundless ocean. But then, about 700 million years ago, they collided and formed Gondwana. This supercontinent included the territories of modern Africa, South America, Australia, India, and Antarctica. The giant pieces crashed into each other and released a stream of hot, partially molten rock. This mess grew bigger and bigger, forming mountains. The temperature of those mountains grew, their mass increased, and at some point, Gondwana became unstable. The supercontinent began to collapse under its own weight. The hot rocks below the surface began to flow sideways as a result of a process called gravitational spreading. Take toothpaste and start squeezing it out of the tube. Approximately the same thing happened with billions of tons of red hot rock. Ancient mountains in Antarctica appeared right during this catastrophic event. You've just watched a visual simulation of global events that took place hundreds of millions of years ago. It looks cool, but how did scientists figure it out? How did they see this planetary scale destruction? If the Gamburtsev Mountains under ice is one of the most unexplored places in the world, then how could people find out its origin? The answer is simple. Tiny particles of rock have told us about the changing landscape of the planet. These are zircons. but scientists also call them time capsules. This mineral is very handy and resistant to mechanical and chemical influences. It's difficult to crush, it doesn't get affected by erosion, and it doesn't dissolve in water. And there's uranium inside it. This chemical element shows scientists the age of the rock. The fact is that uranium always decays into lead at the same rate. Scientists look at the ratio of uranium and lead and determine the age of minerals with great accuracy. Okay, this sounds a bit complicated. Here's a simple example. Imagine that each mountain belt is a clock that starts ticking at the moment of its formation. That is, after the collision of tectonic plates. After the rock forms, uranium begins its slow decay. The more time passes, the more uranium turns into lead. The rate of this decay is always the same. This decay can last for billions of years. The less uranium is in zircons and the more lead, the older the rock is. And this is how it happens in practice. Geologists take several rock samples. In a lab, they crush it to extract crystalline zircons. Geologists then dissolve the particles in acid to separate uranium from lead. Then they use a special device, a mass spectrometer that accelerates atoms and sorts them by mass. This is a rather complicated process, but the bottom line is that this device shows scientists the amount of uranium and lead. They look at the ratios of these two elements and calculate the age of the rock. Geologists took zircons from sandstones near the Gamburtsev mountains, studied those particles, looked at the level of uranium, and calculated the chronology of mountain formation. Then they compared the data obtained with the history of our planet and realized that the mountains buried in Antarctica appeared during the formation of the supercontinent Gondwana. But how did they find out that the supercontinent included Australia, India, and Africa? Zirconia from those Antarctic rocks turned out to be very similar to zirconium from those countries. That is, a long time ago, these three continents were together. So, the Gamburtsev Mountains began to grow about 650 million years ago. About 580 million years ago, they reached the height of the Himalayas, and 80 million years later, they experienced the melting of the Earth's crust. And while most of the mountain ranges on the planet were changing and collapsing, the Gamburtsev Mountains under ice remained untouched. Water, soil, wind, earthquakes, gravity, and other natural forces destroy mountain belts. This process is called erosion. But mountains buried in Antarctica haven't experienced anything like this. The cold temperature and the ice sheet around them kept this range unchanged. It's one of the best preserved ancient mountain belts on the planet. Okay, but why do we need to explore these mountains? What difference does it make that the supercontinent Gondwana collapsed in the past? It's possible that plants, frozen bodies of insects, or ancient bacteria have remained preserved under thick layers of ice. What about ancient animals? Many species could have lived on Gondwana. Studying ancient mountains in Antarctica can show us what the planet looked like about 500 million years ago. When Antarctica was a green continent, what lived on it? What happened to this life? Is it possible to revive those ancient creatures after so many years? If scientists were able to calculate the date of the supercontinent's appearance using tiny particles, then imagine what they could find after examining this hidden mountain range. It all sounds very interesting. But there's one problem. To take a small piece of this unknown world, you need to drill through a lot of ice. You need to deliver heavy equipment to one of the most inaccessible continents in the world, build stations, obtain an energy source, and conduct large-scale research. It sounds incredibly expensive, so this hidden territory will probably remain a mystery for a long time. Let's just hope that some billionaire will want to find out Antarctica's secrets and arrange a large-scale expedition there. A vast expanse of white snow, freezing winds, lifeless landscapes, and weird, eerie signals seemingly coming from within Earth. These radio pulses occur in Antarctica, and no one can figure out what they are and where they're coming from. You see, scientists are running an experiment called ANITA, short for Antarctica Impulsive Transient Antenna. Basically, it's a bunch of detectors strapped to giant balloons and floating way up above the South Pole. Their job is to detect extremely high-energy neutrinos. How do they spot them? Right at the moment when neutrinos come into contact with ice and produce an intense, short burst of radio waves. Now, neutrinos are these tiny, almost massless particles that don't have an electric charge. They're everywhere, and billions of them are flying through you every second, even while you're watching this video. Neutrinos come from all over the place, from the sun, exploding stars, deep space, even from under your feet. The sun pumps them out non-stop as it fuses hydrogen into helium. Stars that are going off blast out huge bursts of neutrinos during supernova explosions. When high-energy cosmic rays hit our atmosphere, they make new neutrinos that rain down on us too. And some even come from radioactive stuff decaying inside Earth. The oldest neutrinos have been flying through the universe since the Big Bang, but they're practically invisible because they almost never react with anything. That's why scientists use unbelievable experiments like ANITA to try and catch even a few of them. But let's get back to that fateful day when everything changed. Normally, the radio signals produced by neutrinos bounce off the ice and fly upward. That's where ANITA can catch them. This is the whole point of the experiment, to study neutrinos and learn more about distant cosmic events like supernovas or whatever's happening light years away. But then something really weird happened. The detectors picked up radio waves that weren't bouncing off the ice at all. They looked like they were coming from below the horizon, from under the ice. Now, this shouldn't even be possible. According to everything we know about physics, signals can't just travel upward through solid rock and ice. One of the researchers, Stephanie Wiesel from Penn State, also said that those radio waves were coming in at super steep angles, like 30 degrees below the surface. The only way that could happen is if the signal had passed through thousands of miles of solid rock before hitting the detector. But if that were true, the rock would have completely absorbed it. So something just didn't add up. The team ran all the numbers and still got no clear answer. But for them, it was an interesting problem, since they didn't actually know what those anomalies were. What they did know was that they were probably not neutrinos.
That's because if the team does detect a neutrino, that means it's traveled an insane distance without bumping into anything, possibly all the way from the edge of the observable universe. So, whatever ANITA has picked up, it's not behaving like anything scientists have seen before. It might mean there's some totally new type of particle out there, or maybe something else is going on that we just don't understand yet. They published the findings in physical review letters, but the mystery remains unsolved. No one really knows what's going on under that Antarctic ice, just that something out there isn't playing by the rules. Now, if scientists actually manage to detect and trace where those crazy fast particles come from, they can learn tons of stuff about the universe. Way more than even the biggest, most expensive telescopes allow us to see. You see, neutrinos basically zip through space almost at the speed of light, barely bumping into anything. It means they can carry untouched data about events that happened millions or even billions of light years away. That's why WHISTLE and a bunch of other researchers around the world have been building these insanely sensitive detectors to catch neutrino signals. Even the tiniest ones are super important, because in this field, one tiny blip of data can hold a treasure chest of information. So, researchers have been designing setups in both Antarctica and South America to catch these rare particles. ANITA is one of those detectors, and Antarctica's the perfect spot for it. There's hardly any radio noise, there are no cities, no traffic, and no random interference. The setup is actually pretty cool. They attach a cluster of radio antennas to a giant balloon, send it a few dozen miles up into the sky, and make it float over the endless stretches of white ice. From up there, it points downward, listening for faint radio signals coming from deep inside the ice. When one of those super rare neutrinos, specifically a tau neutrino, hits the ice, it creates another particle called a tau lepton That lepton then shoots out of the ice and starts breaking down, losing energy and turning into smaller bits. That decay process gives off what's called an air shower, kind of like a spray of invisible sparks flying through the air. If we could actually see those air showers with our eyes, they'd look like someone waving a sparkler through the dark, bright streaks trailing behind as it moves. Studying the direction and pattern of these signals, the ones from the ice showers, and the ones in the air showers, scientists can figure out where the original particle came from. Usually it's super precise, kind of like bouncing a ball off the ground. You can predict where it'll go. But these weird new signals don't bounce the way they're supposed to. The angles are all wrong way steeper than anything the models can explain. So the team dug deeper. First, they looked at all the data from Anita's multiple balloon flights. Then they compared it against tons of computer simulations of cosmic rays and neutrinos and filtered out all the usual background noise. They even cross-checked their results with other experiments like the ice cube detector, which is also located in Antarctica, and the Pierre Auger Observatory in Argentina. They wanted to see if anyone else had picked up similar upward-going air showers. And guess what? Things got even weirder. They found nothing. No other detectors had picked up anything that could explain what Anita had seen. That's why the researchers ended up calling the whole situation anomalous. It basically means, yeah, we have no idea what this is, but it sure isn't behaving like a neutrino. Whistle explained that the signals just didn't fit into the usual picture of how particles were supposed to act. Some people have floated ideas, like maybe it's some new kind of physics, or a hint of dark matter. Dark matter is basically that invisible stuff that keeps the universe from falling apart. It's everywhere. We just can't see it. Scientists have been trying to figure out what it actually is for almost a century, and it's still one of the biggest mysteries out there. Everything we can see, like stars, planets, people, dogs, makes up only about 5% of the universe, and dark matter makes up around 27%. The rest is something even stranger called dark energy. Scientists think dark matter is what gives galaxies their shape and holds everything together like cosmic glue. Without it, the universe would look totally different. It would be totally amazing to find out that this theory is true. But since IceCube and Auger haven't caught the same thing, that really limits the possibilities. Penn State has been in the neutrino detecting game for almost a decade now, building detectors and analyzing all kinds of cosmic signals. And the team is already working on their next big project, a brand new detector called Puel. It's going to be bigger, more sensitive, and way better at spotting those elusive neutrino signals. For now, this remains just one of those long-running cosmic mysteries that keep scientists awake at night. But the team is optimistic. When Pueo goes up, it'll have better sensors, which means if there really are more of these anomalies out there, this time they'll catch them. And maybe then we'll finally figure out what's behind them.
Scientists just discovered a lake in Antarctica that flips everything we thought we knew about life on Earth. They drilled through thick ice and found liquid water where everything should be frozen solid. And inside this water, there is life. I mean actual living organisms thriving in the dark, untouched for ages. The story starts with an expedition that added a new, super important spot to the Antarctica map. Between November 2019 and January 2020, researchers trekking across the frozen desolation reached an area called Enigma Lake. They thought they were walking over a huge slab of solid ice, but their gear showed something different. So they used a powerful drill to get through the ice, peered beneath layer after layer, and detected at least 40 feet of liquid water trapped under the surface. They came looking for a rock, but found a hidden world under ice in this Antarctica lake, where they would least expect it. The scientists were shocked and didn't stop at this discovery. They wanted to know where all this water came from, because in this part of Antarctica, the climate is ruthless. Extreme temperature, low precipitation, punishing winds, and solar evaporation aren't exactly perfect conditions for a lake. Any fresh water was supposed to have dried up long ago. So there had to be a source for refills for a subglacial lake in Antarctica like this one. The researchers looked at the chemical composition of the salts and dissolved materials in the water. They noticed some patterns that pointed to a source. It looked like the nearby glacier was feeding the lake via some underground pathway nobody expected to exist. So there it is, an amazing Antarctica discovery hidden beneath ice, fed not from rain or surface melting, but from an underground flow that circles the Earth in silence. And because of that, when the team drilled deeper, they didn't just find water, they found a secret ecosystem. Life, where they thought there couldn't be any. Now by life here, I don't mean the kind that waves at us, I mean tiny creatures, tiny structures, microbial communities that evolved in isolation, shielded by the ice, and pretty restricted to their hidden home. They cover the lake bed in microbial mats, not just blobs of algae, but complex, carpet-like mats of microorganisms. Some mats look like thin, spiky coverings, others like thick, crumpled carpets, or even tree-like structures up to 15 inches tall. And these formations, looking straight out of a sci-fi movie about life on distant planets, aren't random specks of DNA floating in water. They are thriving, building structures, layering, changing over time. So the lake bed is kinda like a forest floor, only it's dark, cold, and covered by ice. If life can flourish under 45 feet of ice in near darkness, maybe our ideas of where it can exist need updating. And we don't know what happens when we disturb this hidden lake ecosystem. What if we inject humans, machinery, or even our breath into the mix? These microbes have lived isolated for who knows how many millennia, maybe even millions of years, without any exposure to the world above. If humans mess with them, these organisms could be at serious risk when they meet microbes they had never met before. The lake could get contaminated, and its ecosystem could change for good. As we step into this new territory, we must be extra cautious. After all, the entire Antarctica is like a book of secrets of evolution, adaptation, and survival that we must read carefully. This continent keeps surprising us. Animals that were never seen before turn up in its remote corners, from bizarre sea creatures to ice-loving insects you didn't know existed. For example, the ice-loving sea anemone scientists spotted hanging upside down from the underside of the Ross ice shelf. It looks like a delicate flower glued to the ceiling, waving its tentacles into water as cold as a bad breakup. Researchers steered a robot under the ice and found a brand new species. Then there's the celebrity newcomer with serious red carpet energy, the Antarctic strawberry feather star. This floating pom-pom can have up to 20 arms. It got its nickname because the body looks, you guessed it, strawberry-ish. And oh, I guess Antarctica is the last place where you'd expect to see a fish nursery, but it has the largest known one in the whole world. Researchers were there towing their cameras along the Weddell Sea seabed to map it when they spotted thousands, then millions of identical bowls in the sediment. The nests covered 93 square miles of seafloor, and there were a total of 60 million of them, one every 10 inches. All the nests belong to icefish. These creatures are white-blooded, meaning they don't have hemoglobin, the stuff that makes blood red, and somehow they still manage to survive in water cold enough to shatter your soul. Every nest had a parent fish sitting guard over about 1,700 eggs. Turns out, Weddell seals feast on icefish, so this massive breeding ground isn't just a nursery, it's also a buffet for the neighborhood predators. And speaking of buffets, the icefish themselves feed from a warm upwelling that pulls up nutrients and microscopic zooplankton. It's all pretty cool that the icefish colony has a hard edge, a literal line in the sand. The edge of that border matches perfectly with the outer rim of the warm upwelling, which looks like a carefully crafted evolutionary trick. Another Antarctica discovery that shocked scientists wasn't a cool-looking fish or a dinosaur bone, but something probably even more important for science: bubbles. Tiny ancient bubbles trapped inside what might be the oldest ice ever brought up to daylight, nearly 1.2 million years old. Before this discovery, researchers had recorded climate history going back 800,000 years, but they wanted more. They spent years searching for the perfect spot where ice could tell the story straight through. Some Antarctic regions hold ice even older, maybe 3 or 4 million years. But it's patchy, and they needed a continuous record. When they finally drilled into the right spot, they found crystal clear ice cores with bubbles that trapped the atmosphere of Earth as it was hundreds of thousands of years ago. When scientists analyze the air inside, they're not just studying gases. They can tell what our distant ancestors inhaled, what the planet exhaled, and how the rhythm of life and climate played out long before us. The period around 900,000 years ago, the same time sealed inside this ice, may have been one of humanity's closest calls. According to genetic studies, the human population shrank to about 1,300 individuals on the entire planet. Nobody knows what exactly led to this, but it could have been the climate. So these ancient bubbles might hold the clues we need to understand how our ancestors survived one of the toughest chapters in Earth's story. And maybe how we can survive the next. Because the planet keeps repeating itself in new and uncomfortable ways, and Antarctica has lessons to teach us. One lesson we might learn the hard way has to do with what's under its ice. Scientists recently found that there's something brewing beneath Antarctica that's anything but chill. There might be volcanoes there, quietly waiting for their moment. Yeah, you heard it correctly. Volcanoes, the hot, fiery kind sitting under miles of ice. The team used computer simulations and found that when parts of the ice melt, the pressure holding those volcanoes down eases up. And boom! They could start melting even more ice from below. It's like a self-feeding loop of chaos. The ice melts, volcano wakes up, then more ice melts. Even if humans stopped affecting the climate conditions on the planet tomorrow, that chain reaction could keep going because it's not just about the air. It's about the fire hiding underneath. The scariest part is that this kind of melt could raise sea levels way more than we thought. And since Antarctica has over 70% of all the freshwater reserves on Earth, you can imagine the drama level it could lead to. So you see now that Antarctica map is like a real-life board game for humans, and we must be careful studying and playing it.